Hi all, this video is meant to introduce right triangle trigonometry. For this first problem, we want to find theta, phi, and x both exactly and approximately. You have a couple of options as to what to do first. I am going to solve for theta first. And because I'm looking for theta and I know that the adjacent leg is 12 and the hypotenuse is 19, I will use the cosine function. So the cosine of theta is adjacent 12 divided by 19. Again, that's adjacent over hypotenuse. That's exact, nothing's been rounded. And if we know that the cosine is 12 over 19, then we can say that theta is exactly equal to the inverse cosine of 12 over 19. Again, nothing's been rounded, that's exact. If we want to round, we can type that in. And I'm in degree mode for now. We have not started working with radians yet in class. So the inverse cosine of 12 over 19 kicks out a value of approximately 50.833 degrees. So theta is approximately 50.833 degrees. Now, because this is a right triangle, we've already accounted for 90 degrees and another 50.833 degrees. We can find phi by subtracting 50.833 from 90. And what I should have said is, remember, all the three angles of a triangle add to 180. So if I take 90 and I subtract my previous answer, I'm going to get about 39.167 degrees if I'm rounding to three places. So phi is approximately 39.167. Now, we could check this answer. Again, if I'm going to use 12, because I know 12 and 19, I could start by saying that the sine of phi is opposite 12 over hypotenuse, and I keep writing 19, opposite 12 over hypotenuse 19, and so phi is equal to the inverse sine of 12 over 19. Again, that's exact, nothing's been rounded. If I want to approximate, I'll type in the inverse sine of 12 divided by 19, and I get out my 39.167 that I've already found. Again, just to check. And so lastly, we want to solve for x. I would use the Pythagorean theorem in this case, and I would start by saying 12 squared plus unknown x squared is equal to 19 squared. Now 12 squared is 144, plus x squared is equal to the square of 19, and the square of 19 is 361. We'll subtract 144, and we get 217. And so x is exactly equal to the square root of, that's a 7, square root of 217. Again, that's exact. Nothing's been rounded. If I wanted to approximate, I could type that in, and we'd get approximately 14.731. Now, just for kicks, quick review of these ratios, the trig ratios, sine, cosine, and tangent. If I wanted to now determine what let's say the tangent of theta is, then I would say opposite, which is square root of 217, over adjacent, which is 12. Or, for example, the tangent of phi, opposite 12 over the square root of 217. Notice that in each of those cases, again, nothing has been rounded. Those are exact. Next example, we want to find m, n, and phi both exactly and approximately. And the place that I would probably start in this instance is I'm going to go ahead and just say that phi is equal to exactly 60 degrees. We know that phi is 60 degrees because this angle was 30 and this angle was 90, and again, the angles, three angles of any triangle add to 180 degrees. Now, if I want to find m next, again, we know both of these angles. You can use either then to start, but I might say that the tangent of 30 degrees is equal to 190 over m. So the tangent of 30 is equal to opposite over adjacent. I'll move m up through multiplication, and so m times the tangent of 30 is equal to 190, and m then is equal to 190 divided by the tangent of 30. Now, that's exact, nothing's been rounded, and we haven't talked specifically about this special angle yet, the tangent of 30 degrees, but we will soon, and in a few more days of class you'll be able to simplify this even more, but for now we'll just call this 190 over the tangent of 30. Okay, that's exact. If I wanted to approximate that, then I could type that in, and so 190 divided by the tangent of 30 comes out to approximately 329.090. Now, in order to solve for n, you have a couple of options. You could certainly use the Pythagorean theorem. You know these two sides, and so a squared plus b squared equates to c squared because we have a right triangle. You could also use 30 degrees and opposite 190 and hypotenuse. So in that case, you would use the sine of 30. Or you could use your 60-degree angle and use adjacent over hypotenuse. I'll go ahead and use 60 degrees. So I'll start by saying that the cosine of 60 is equal to adjacent 190 over hypotenuse n. N, therefore, is exactly equal to 190 over the cosine of 60. That's exact, nothing's been rounded. Again, this number here we will talk more about in an upcoming class, and you'll be able to simplify this even more, but for now we'll leave it at that. And we could say that n then is approximately equal to, well, it's exactly equal to 380 because the cosine of 60 is 1/2. And again, we'll talk more about that in section 7.2. Next example, this is more of a vocabulary example. I just want to talk about the angle of elevation and what that means. Find the angle of elevation and the angle of depression in this case. So we have a plane flying at an altitude, and an altitude is makes a 90-degree angle with a horizontal. So an angle, find the angle of elevation, theta in this case, if a plane is flying at an altitude of 20,000 feet and is 8 miles away from someone standing on the ground. Okay. Well, the first thing we want to do, we've got this problem where we have feet as one unit and miles as another. So I'm going to take 8 and I'm going to multiply it by 5,280 because there are 5,280 feet in a mile, and that'll convert this to feet. So 8 times 5280 gives me 42,240 feet. And so now I have the same unit, feet and feet. If I want to find theta, I'll use the tangent function because look at what we have. We have this angle, we have the opposite leg and the adjacent leg, so that tells us to use tangent. So the tangent of theta is equal to opposite 20,000 divided by adjacent 42,240. And theta then is equal to the inverse tangent of that value. So when I punch that in, I get approximately 25.337 degrees. Now that has been rounded, and we call that our angle of elevation. Now, an angle of elevation is actually equal to the angle of depression over here. So this is the same angle, and this is again our angle of depression. I often see students get confused thinking that this is the angle of depression, which is why I wanted to talk that out. This is not the angle of depression. The angle of depression is this angle, which is the same as the angle of elevation. So just more of a vocabulary example there. We have two more. A line passing through the origin and the point 17B forms an angle of 37 degrees with the x-axis. Find the missing coordinate B. So through the origin and through this point, and we don't know what B is, but we do know that it forms an angle of 37 degrees with the x-axis. So let's sketch. I'm going to go through the origin, so we'll go through this point, and we're going to go out 17 units and up B units. We don't know what B is. Okay, but we do know that our angle formed with the x-axis is 37 degrees. This is a 37-degree angle. And we are solving for this distance right here. If you think about it, you're solving for the vertical distance because this is the output of this ordered pair, 17, comma, b. We're solving for b. So, look carefully, and you should see that we know that distance is 17, we know that distance is b, and we know that angle. So we're going to use the tangent function. In the coordinate plane, that's going to be a 90-degree angle, and so we can state that the tangent of 37 is equal to opposite b over 17. B then is exactly 17 times the tangent of 37. That would be one way to express b. Again, we're in degree mode. That's exact, nothing's been rounded, but if we wanted to approximate, then we could type that in, 17 times the tangent of 37, and we get approximately 12.810. So b is approximately 12.810, meaning that we would have gone up about 12.810 units in order to get to that ordered pair. Last but not least, a similar example to the previous one, except we do not go through the origin this time. Find the measure of the acute angle, acute meaning less than 90 degrees, formed by y is equal to negative 3x plus 11 in the x-axis. Sketch this thing. So, sketch doesn't have to be perfect. We have a decreasing linear function with a y-intercept of 11. So I'll sketch that. There's my y-intercept of 11. We are decreasing. Okay? And what we're solving for is the acute angle formed with the x-axis. So we're solving for theta. Of course, we know that this is a 90-degree angle. We know that this distance right here is 11 from here to here. That distance is 11. We have a y-intercept of 11. Okay? And my suggestion would be to go ahead and solve for this distance and then use the tangent function. Now, why don't you pause it for a moment and think about how you could solve for that distance. Okay, so if I want to solve for that distance, I can just find the x-intercept. And how do we find an x-intercept? We put 0 in for y. So I've got 0 is equal to negative 3x plus 11. I'll add 3x to both sides. I'll divide by 3. And I've got x is equal to 11 thirds. So this distance is 11 over 3. Now we know this distance and we know this distance. We can now say that the tangent of our unknown theta that we're trying to solve for is opposite. That's 11 divided by 11 thirds. Well, dividing by 11 thirds is the same as multiplying by 3 over 11. 11 times 3 over 11 is 3. And so the tangent of theta is 3, but we want to solve for theta. And so if I want to solve for theta, I'll take the inverse tangent of 3 in this case. That's exact, nothing's been rounded, and if you wanted to round, you could take the inverse tangent of 3, and I'm getting approximately 71.565 degrees. We're still in degree mode. We'll talk about radians soon. That's all I've got.